Okay na, recording na.
Ah,
So, hello miss, this is a group review sa calculus and the members are Joshua Pontilla, Russell J. Pontino nga naman, tama.
um,
Jaydie Plaza, Jayze Rana, and ako po, Yuval Ramos. So, game.
ang una ano.
So ngayon, panoorin po namin muna yung video na pero napanood na po namin individually po. Start. Walang sound.
Teka lang, hindi ko mahanap. Nasaan na yun?
Yung net lang. Sorry po.
Ulit
Okay
ko.
lang, hahaba yung ano natin.
Ayan.
Good day, welcome back to
Lang.
Engineering Calculus 1 or Differential Calculus. For today's lesson, we will be discussing the first derivative test. First derivative test or FDT. Without calculus, we don't know the exact behavior of the curve between the points we plot. Even if we plot hundreds of points and connect them with the line segments, the maximum and minimum values of the curve could not be determined accurately. In this lesson, we will use derivatives to determine the behavior of a continuous function on a certain interval, whether it is increasing or decreasing, and to find the relative extreme of a function on that interval. The increasing function f of x is defined on an interval that is said to be increasing on the interval if and only if f of x sub 1 is less than f of x sub 2 whenever x sub 1 is less than x sub 2, where x sub 1 and x sub 2 are all numbers in the interval. While the decreasing function is said to be decreasing on the interval if and only if f of x sub 1 is greater than f of x sub 2 whenever x sub 1 is less than x sub 2, where x sub 1 and x sub 2 are any numbers in the interval given. This is the theorem that we need to consider. Let f of x be a function that is continuous on a closed interval ab and differentiable on the open interval ab. First, if f prime of x is greater than 0 for every x in open interval ab, then f of x is increasing on the closed interval ab. If f prime of x is less than for every x in open interval ab, then f of x is decreasing on the closed interval ab. Take note of the graph. F is increasing on the plots on the closed interval a and b. While on this part, f is decreasing on closed intervals a and b. Take note that this is our intervals a and b, or the limits a and b. For example number 1, let y equal to f of x equal to x cubed minus 3x squared minus 9x. Find and intervals on which f is decreasing and sketch the graph of the function. Our solution is to differentiate y with respect to x, and solving for x, it will give us 2 dy over dx equal to 3x squared minus 6x minus 9 after differentiating this or taking the first derivative, and then we can have this as 3 multiplied by x plus 1 multiplied by x minus 3 to solve for x. And then we have that as x sub 1 equal to negative 1 and x sub 2 equal to negative 3. If you divide both sides by 3, this will cancel out and this is 0. Solving for the two values of x, you have x plus 1 equal to 0. That means x is equal to negative 1, and x minus 3 equal to 0, and that is x equal to 3. So I hope you can still recall the factoring method that we've discussed in the fundamentals of engineering mathematics. To find the x-intercepts in the given function, we set y equal to 0, then solve for x. Hence, we have 0 equal to x multiplied by x squared minus 3x minus 9 coming from this one. And that will give us x is equal to 0, 4.9, and negative 1.85. Please use your calculators as I take note on this one. And from the previous theorem, it is sufficient to find the intervals in which the f prime of x is greater than 0. So with that, we have here as intervals our f of x, our f prime of x, and our conclusions. So for x is less than -1, our f prime of x is positive. Okay, so therefore our f of x is increasing. Now, if my x is equal to -1, directly equal to -1, the answer for my f of x, solving for that, coming from this part, would be 5. Use your calculators for that one. And my first derivative, okay, solving for that, and substituting -1, that would be 0. So therefore, f of x is a relative maximum value. And from the intervals -1 to 3, we cannot determine that, but the answer would be negative. So therefore, f of x is decreasing because that is from 5 to -27. Take note of this one. As we solve for this one, x is equal to 3, that is another root, okay? That is another interval. Solve for the f of x, that will give you -27. And after solving for the first derivative, okay, this is your first derivative, and substitute again the value, that will give you 0. Okay, and then f of x therefore has a relative minimum value, and for x greater than 0, the values for f prime of x would be positive, therefore f of x is still increasing. This would be the graph for that one. This is the relative maximum, -1 and 5, and the relative minimum, 3 and -27. You can graph this using the table, or you can create another table. You know how to create table in order to form graphs. So that is how we do our relative maxima, minima, extremes, intervals, and sketching of graphs. You can use also the original equation to solve for this one. X is -1, y is equal to 5, and x is equal to 3, y is equal to -27. Now, for the first derivative test, suppose your f of x is continuous at a critical number x sub 0 and differentiable on an open interval a b containing x sub 0 except possible x sub 0 itself. So we have here the rules. If f of x is positive for all x, then we have a relative maximum value. If f of x is negative to the left, then we have a relative minimum value. But if we have f of x greater than 0 or f prime of x less than 0 for every x in the interval except x at x sub 0, then it is not a relative extremum. This means no relative extremum occurs at those critical points. So we have here a relative maximum point wherein our f prime of x sub 0 is equal to 0. This is less than 0 and less than 0 for our f prime of x, and this is our relative minimum point at x sub 0 where f prime of x sub 0 is equal to 0. You can test that out. That's why it is called first derivative test. Just test if the answer would be equal to 0. For example, number 2, find the relative extrema and sketch the graph of the given function. So
Nakamute.
So yung example 1, medyo madali lang. So dito, ang ano natin, example 2. Ang gawin natin example para mag-gets talaga natin. So, yung sa PPT natin, nga, para i-apply natin yung natutunan. Doon tayo sa question muna. Yan. So, example 2, find the relative extrema and sketch the graph of y is equal to 1/2 x minus 1 squared times 4 minus x. So, first, ang sinabi sa atin ni Miss is derivatives muna. So, ang turo sa atin ni Miss, isa-isahin natin. So, i-recall natin yung dati yung mga yun? Yung sa mga derivatives na sample ni Miss. So, ang given sa atin ngayon ay UDV wait lang. Y is y tas quantity U times V. So, ang formula dyan, UdV plus VdU. So, ang U natin, 1/2 x minus 1. Palakihin mo nga doon. Kaya bang palakihin? Ayun, no. Nasa UdV plus VdU. Yan yung sa example ni Miss. Ang U natin, 1/2 times x minus 1 raised to 2. Then, ang V natin is 4 minus x. So, isa-isa natin U. Pag derivative natin, yung 2, ibababa natin dun sa Ngayon, kaya 1/2 pa din yung nandito sa dy over dx. Kasi kasi 1/2 times, yung kalahati ng 2 is 1. So, 1/2 pa din siya. Gets? Kaya ang, tapos, kaya 1/2 minus, negative 1/2 times x minus 1 raised to 2. Next is, V. So, V, 4 minus x. So, ang derivative of a constant, 0 lang. So, yung 4 magiging 0. Then, yung x, 1. Kasi, may raised to 1 yan. Tapos, mawawala na yung x kasi minus 0 na. So, ang dv, 1. So, u is equal to 1/2 x minus 1 raised to 2. Tapos, di ba, u dv, then dv is x minus 1 raised to 2 plus 4 minus x times x minus 1. So, ang sunod na ginawa dyan ni Miss, yung x minus 1, inuna niya. Kasi yun yung magiging first x natin. Pansinin nyo, x is equal to 1. Kumbaga, transpose lang. Kaya naging positive yung negative 1. Ngayon, kailangan na natin hanapin yung second x. So, ang gagawin, i-assume natin yung yung mga natira doon sa other side. Gagawin natin yung mga natirang x, i-assume natin magiging x sub 2 siya. Kaya naging negative 1/2 x sub 2 minus 1 plus 4 plus quantity, then 4 minus x sub 2 is equal to 0. Ngayon, kaya nakuha ni Miss yan, ito yung ginamit yun dito, yung nasa gilid. Yung 1/2 kumbaga itinimes, kasi dahil nga negative 1/2 yan, i-over to natin. I-over natin doon. Kaya pareho sa denominator na 2. Tapos yung sa taas, x sub 2, negative x sub 2, kasi nga negative yon plus, negative x sub 2 over 2, plus, 1/2, kasi 1, tas, di ba, yung 2 yung denominator. Then, ganun lang, i-copy lang yung 4 minus x plus 4 minus x sub 2. Sunod dyan, yung itatranspose, tama ba? Wait lang. Wait lang, but bigla ako nalito. Ba't may 4.5 yan? 4 point. Yun. 1/2 plus 4 is equal to 4.5. Di ba may 1/2 dyan? Wala namang x yun. Kaya pinag-plus. Ngayon, pinagsama yung yung common, yung pareho, yung may x sub 2. So, minus x sub 2 over 2 minus x sub 2. I-equate natin yan sa 0. Tapos ngayon, ano sunod ginawa dito ni Miss? 4 minus x sub 2. Papabayin na lang natin yung video. 3. So, 4.5. 2. Over 1. Nag-gets nyo ba? Bigla ko nandito. Kanina nag-gets ko na. Okay. Lang, x sub 2 minus Patay na kayo dyan. Except to... Lah, di ko makuha. GG tayo. Di ko makuha.
Jayze,
Ah,
try mo i-divide yung ano. Try mo i-divide sila sa 2 para mag-cancel yung 2. Gets mo?
paano x sub 2 minus x sub 2 is equal to 4.5 tas i-divide ko by 2 lahat?
Oo.
Wait lang.
Try ko nga din.
Try nyo nga. Bigla ako, dyan lang ako nawala. Ano ba yan? Kanina gets ko. Negative 1 minus ano. So yung calcio ko. Try nyo nga sagutan. Negative 1 half.
Ba't nga pre naging negative 1/2 yun?
Kasi, yung ano yun? Bakit? Naging negative 1 half?
Oo, yung dyan. Yung doon sa pinakataas.
Wait lang.
Kuha ko na, Jayze.
Paano? Send mo nga picture.
Tingnan mo nga kung kita to. Ito ba yung ginagawa mo?
Pati, ang liit. Ba't di lumalaki yung ano? Exab. Isabihin mo na nga lang. Kung paano yung ano.
Di baga, yung ano, yung 4.5 minus x squared divided by over 2
2.
minus x squared is equals to 0. Times
0.
times mo yung equation sa 2 para makancel yung 2
Ay, and
dun sa
yung both sides sa
negative
2.
x squared. Oo. Tapos yung ang sunod ay pag pinag-times mo na, di 9 minus x squared minus 2x squared. Tapos, pagpa-plus mo yung dalawang variable na x squared, di magiging negative x squared minus plus 9. Di yun. Ilipat mo na lang, transpose mo na lang. Tapos makukuha mo na yung...
Ayun.
Tapos makukuha mong sagot ay 3.
9 divided by 3 kaya naging 3. Ayun.
Oo.
So yun, nakuha na natin yung kung paano naging 3 yun. Ano ba yung pahirap? Sunod, next slide na yung dun sa na natin yan. Sketch. Ayun yung, yan. Palakin mo nga din ulit. So ang natin, interval, yung sa table ni Miss, if x is less than 1, ang gagamitin natin 0. Then x is equal to 1, edi 1. Ngayon, negative, di ba ang x sub 1 natin ay 1 at x sub 2 ay 3. Ngayon, sa gitna, hanapin natin yung gitna niya. So, ang gitna ng 1 is less than x and less than x is x is less than 3, so 2. Then, pangatlo, x is equal to 3. Tapos ngayon, x is greater than 3, kaya naging 4. Now, value of x. So, pag sinubstitute natin yung x into 2, dun sa equation, ang kakalabasan niya 2. Then, pag 1, 0 siya. Tapos pag gamit yung 2, ang kakalabasan 1. Then pag 3, 2 din. Tapos yung pag 4, 0 lang, 0 yung lalabas. So ngayon 2, ang niya, negative, negative or decreasing siya. Kasi, di ba, ang napag-usapan kanina, if x sub 1 is less, if x sub 1 is less than x sub 2, increasing siya. Pero dahil dito, dahil nga 2 siya, kumbaga mas malaki siya dun sa 1, anong nangyari, ang nangyari, mas mataas yung x sub 2, kaya negative siya, decreasing. Tapos yung sa 0, kaya hindi naman natin madedetermine 0 nga. Tapos dito sa kaya 1, yun. Kasi mas maliit siya dun sa kaya increasing siya. So, relative maximum, dahil din money.
Nangyari sa mic mo, bro. Yan ako.
May problema? So yan,
Ulit
kaya
mo,
nung
okay na.
yung yung mic mo kanina.
Saan? Saan part?
Doon lang sa may part na doon sa may value of f prime x na yun.
F prime x, yun.
Doon sa may...
So, una.
Pang-apat.
Okay. Pang-apat na, no? Itong
Oh,
value of
binata.
f prime x.
Hindi lang sa simula.
Sige, simula daw.
Saan ba? Sa x uli ako?
Sa prime.
Diyan, sa may
F
simula.
prime
Dito
x.
sa may...
Ha?
Dito.
Yan, doon sa tinuturo na ni RJ.
Ayan. So, simula. Di ba ang sabi kanina, if x sub 1 is less than x sub 2, increasing siya. Pero if x sub 2 is greater than x sub 1, decreasing. So dito, kaya yung sa value dito sa x less than 1, kaya negative siya, decreasing. Kasi nga, mas mataas yung 2 doon sa 1. Gets nyo? Next is, dito, 0 yung sagot, kaya hindi natin ma-determine kung increasing or decreasing. Kumbaga, 0 yung, 0 pala yung, nahihilo na ako. 0 yung relative minimum kasi yun yung lumabas nung, sinubstitute natin yung 1. Then, yung 1, yung value, kaya, increasing naman to kasi yung 1 ay less than doon sa x sub 2. Gets nyo? So, tas sunod, ang relative maximum 0 din. Then last, f yung 0 siya, negative decreasing naman siya. So, doon na tayo sa graph. Ang x sub 1 natin is 1, kaya nag-start siya sa mababa, doon sa 1. Then, nung sinubstitute natin siya 0, kaya 1 tapos 0. Yun yung relative minimum natin. While yung relative maximum natin, yung x sub 2 natin, 3, while nung sinubstitute natin yan sa formula, ang kinalabasan, 2. Kaya 2, 3, 2. So, ang sketch na ito, increasing. Kasi mas maliit yung x sub 1 sa x sub 2. Proceed na tayo sa next video.
Next lesson.
Good day, welcome back to Engineering Calculus 1 or Differential Calculus. For this lesson, we'll be discussing transcendental functions. Transcendental functions, we have three types, the logarithmic and exponential functions, which we are done discussing, by the way. Number two would be trigonometric and inverse trigofunctions. Number three, hyperbolic and inverse hyperbolic functions. Note that each pair of functions above is an inverse to each other. Here are some of the trigonometric functions. Recall trigonometric identities. We have your number one, sine of x. Reciprocal is cosecant x, cosine is secant, tangent is sine over cosine, cotangent is cosine over sine. We also have here the sum and difference of two angles. The sine x plus y, we have here sine x cosine y plus cosine x sine y. Number two is for the cosine x plus y. Number three would be for the tangent. Letter C would be for the double angle formula. We have sine 2x. The equivalent is 2 sine x cosine x. We also have cosine 2x, which we have 1, 2, and 3 identities which we can use. And tangent 2x would be 2 tangent x all over 1 minus tangent squared x. And we also have squared identities wherein we have sine squared x plus cosine squared x is equal to 1, as well as 1 plus tangent squared x equal to secant squared x. And number 3 is 1 plus cotangent squared x equal to cosecant squared x. I've already given all this to you during your fundamentals. That's why this is a recall. We will be using all of this as we simplify trigonometric functions and take its derivative. So for the differentiation formula, the derivative of the trigofunctions. For the formula of trigonometric functions, all you need to know is the differentiation formula of sine u and cosine u. Using this formula and differentiation formulas of the algebraic functions, the differentiation formula of the remaining functions, tangent, cotangent, and secant, and cosecant may be obtained. So you just need to remember and memorize this. The sine u, where u is f of x, is equal to cosine u du over dx. So do not forget du over dx. Sine u is equal to cosine u, whatever the variable here is, and its derivative multiplied by its derivative. While cosine u, where u is f of x, is equal to negative sine u du over dx. From these two formula, you can solve for the differentiation formula of tangent, cotangent, secant, and cosecant using derivations and so on. But if you want to memorize also the formula for differentiation of tangent, cotangent, secant, and cosecant, you may do so. For the derivative of tangent u, where u is f of x, we have tangent derivative of sine x cosine x over cosine x using the derivative of quotient, which is, again, this is v du minus u dv over v squared. So we have here v derivative of u sine, this is derivative of sine x minus sine x derivative of cosine x all over v squared, which is cosine squared x. So let us solve for the derivative of both sine x and cosine x. We have cosine x minus sine x multiplied by negative sine x all over cosine squared x. And we have here cosine squared x plus sine squared x all over cosine squared x. From letter D, squared identities, this is equal to 1 all over cosine squared x. And simplifying this, we have the derivative of tangent as secant squared x. So therefore, derivative of tangent x is simply secant squared x. You can use tangent or derivative of tangent u over dx is equal to secant squared u du over dx. Do not forget this, du over dx. Now, the derivative of cotangent u, where u is f of x, we can use the reciprocal, which is 1 over tangent. Using the derivative of quotient, you can use v du minus u dv all over v squared. We have 0 minus 1. Okay, derivative of tangent all over tangent squared x. And solving for the derivative of tangent, we have secant squared x. Applying and simplifying those formulas, we can have secant as 1 over cosine. our tangent as sine over cosine, but this is in squared, so we have your sine squared and cosine squared. Simplifying this term, this will cancel out. Cosine and cosine squared will cancel out. This is equal to negative 1 sine squared x, and that is equal to negative cosecant squared x. So therefore, the derivative of cotangent x is equal to negative cosecant squared x. We can say that the derivative of cotangent u is equal to negative cosecant squared u du over dx. For the second, we still have the same derivation using 1 over cosine and using the derivative of a quotient, applying the formula of v du minus u dv all over v squared to this given, you will arrive to the answer of tangent x secant x. And therefore, the derivative of secant u with respect to dx is equal to tangent u secant u du over dx. For the derivative of cosecant u, we apply the reciprocal, which is 1 over sine, and use the derivative of a quotient again. Applying the formula of derivative of quotient, you will arrive to negative cotangent x cosecant x, and that will give us derivative of cosecant u over dx is equal to negative cotangent u cosecant u du over dx. So this is the summary. If u is a differentiable function of x, then the following are differentiation formula of the trigonometric functions. Letter A, let us find the derivative of the following functions and simplify the result. Given f of x is equal to 2 cosine x minus 6 secant x plus 3, applying sum and difference rule, the derivative of 2 cosine x minus derivative of 6 secant x plus the derivative of 3, we have that 1 by 1, okay, per term. 2 cosine x is negative 2 sine x, okay, because we have a 2 here of the derivative and apply derivative on cosine, which is sine x, and the derivative of x is simply 1, so we have here an invisible multiplied by 1, so that is simply negative 2 sine x. For the other one, we have 6 secant x, and the derivative of secant x tangent x, we have a constant 6, so bring that out of the differentiation formula. And the derivative of x is simply 1, so we have here an invisible multiplied by 1. And lastly, the derivative of a constant is 0. Combining the 3, we have negative 2 sine x minus 6 secant x tangent x plus 0, or simplifying, we have negative 2 sine x minus 6 secant x tangent x. So this is our answer for example number 1. For example number 2, we have g of x equal to 10 tangent x minus 2 cotangent x, applying the sum and difference rule. For this, we have 1 by 1 10 tangent x is equal to 10 secant squared x. For cotangent, the derivative is cosecant squared x. Sorry, that is negative cosecant squared x. And since we have constants before the function derivative equation and solve for the derivative of tangent and cotangent, then we have your answer as 10 secant squared x minus negative 2 cosecant squared x. Simplifying, the answer would be 10 secant squared x plus 2 cosecant. Let us have example number 3. H of x is equal to x cubed minus x squared sine of x, applying sum and difference rule. So we distribute the d over d of x for each term, solving for the derivative of x cubed, that is 3x squared, and solving for the derivative of x squared sine of x, that is 2x sine of x minus cosine x squared. Okay, so combining all, we have 3x squared minus the quantity 2x sine of x plus cosine x squared. Simplifying, we have the answer as 3x squared minus 2x sine of x minus x squared cosine x. We have examples 4, 5, and 6 as presented. Here are the following solutions and try to solve on your own. Check that out. You can have a different solution from what I have, but for number 4, this one is direct substitution. For number 5, take note we have here e to the u. So solving for e to the u, that is equal to e to the u du. And for letter H, that is simply cosine. Again, this is, you'll be using some identities for number 6. Now, let us proceed to the derivatives of inverse trigonometric functions. Let u be a differentiable function of x given derivative of arc sine. Again, if you have an arc in the beginning of each trigo functions, that means that is sine negative, cosine negative 1. Okay, you have a negative 1 as the exponent, or you read that as arc sine, arc cosine, and so on. So this will be our formula for arc sine. You have your u prime. When we talk about u prime, that would be the derivative of the given u. Okay, this is du as well. Du or u prime is the same. For cosine, arc cosine, that is actually similar to sine, except that you have a negative in front of your equation. And for the arctan, you have your 1 plus u squared. For the arc cotangent, that is, you have negative here compared to tangent. And for secant and for cosecant would be this formula. Everything would be direct substitution. If you have the value of your u as a function of x, just take its derivative and have it on the numerator and directly substitute square root of 1 minus whatever the function here is, and then simplify. Okay, find the derivative of each of the following functions and simplify the result. Y is equal to 1 over arc sine of x. We have that as I can replace this as in the format of power. Okay, I can bring it to the numerator and that will become negative 1. So if I'll be using power rule here, I'll be having negative 1 in front, sine x negative x, or sine arc sine of x raised to negative 1 minus 1 would be negative 2, and the derivative. Okay, do not forget the derivative of your u. So this is sine arc sine of x. Therefore, the answer would be negative 1 over the quantity arc sine x squared multiplied by 1 over x squared. For letter B, f of x is equal to x arctan of x, arctan of square root of x. That will become, you have here a variable x, and then follow the format of the arctan. That will be 1 over 1 plus the quantity square root of x multiplied by 1 half x raised to 1 half plus arctan of x. And therefore, the answer would be square root of x all over 2 multiplied by 1 plus x plus arctan of x. So that is how we solve directly for inverse trigo functions. That is all for this lesson, and you may now proceed to your seat work number 8. Solve the following. Solve for
So, yun lang naman yun. Pag kailangan nyo lang sa ulo yung, ang tawag doon, yung mga identities, yung makikita nyo. Yan, kailangan nyo sa ulo yan, yung trigonometric functions na yan, yung mga trigonometric identities. Mostly, ang mga lumalabas naman sa mga given is, basta ang importante sa ulo nyo dyan, yung reciprocal identities, tsaka yung squared identities. Kasi sa mga given naman ni Miss, mostly ang mga lumalabas naman dun is yung mga sin x, cosine x. Bihira lang siguro yung mga yung sin 2x, yung mga cos 2x, yung tulad sa double angle formulas. Di ba, sa given ni Miss, di man gaano lumalabas yung mga given na gano'n. Tapos, yung pinakita ni Miss dun sa video na yung kung paano kunin ang, ito, yung mga derivatives of trigonometric function. Yan, ipinapakita lang diyan kung paano kunin yung kanilang, kumbaga yung para equivalent baga, tama baga? Yung equivalent ba? Kasi yun, kung ano yung sagot, yun na yung parang meron na kasi yung pinakita ni Miss na summary na na derivatives of trigonometric function. Pakita mo nga pre yung yung isa, yung dito. Yung isa. Hindi yan, yung isang may screenshot ba tayo nun? Ay, wala tayong screenshot, di na isama. Basta yun, di yan pinapakita lang kung ano yung derivative ng derivative ng tangent mga tan x, yung sin x. Yun lang naman yun, pinapakita lang kung paano kunin yun. Yun lang. Kaso di ko alam kung paano kunin yung arc sign na yun.
Move. Okay, move na tayo sa next video.
Siguro lang, gawin na lang dun sa part na yun. Dun sa yung arc na yun, i-search na lang natin sa YouTube, tas mamaya pag-usapan na lang. Sa Jayze. Okay, yun na lang.
Okay, next video tayo.
Back to Engineering Calculus 1 or Differential Calculus. For today's lesson, we'll be discussing maxima and minima involving trigonometric functions. Strategy for solving applied maxima and minima. Number 1 is to set up the equation whose maximum or minimum value is required. Make the necessary figures or illustrations to make the solution clearer and easier. If the resulting equation involves more than one variable, express these relations in terms of one variable using the sufficient conditions given in the problem. And lastly, apply the first and second derivative test. For example number 1, a rectangular storage area is to be constructed.
Sagutan mo na ba to, Jayze? Mapapanoorin.
Sige, doon tayo sa PPT. So dito sa maxima and minima involving trigonometric function, ang pinaka inaano ni Miss sa atin, matutunan natin na kung paano i-draw yung nasa question. So ang given a rectangular storage is to be constructed along the side of a tall building. So ang doon, may tall building na tapos may co-construct pang another. So a security fence is required along the remaining three sides of the area. What is the maximum area that can be enclosed with 800 meter of fencing? So yun nga, sabi daw may co-construct na rectangular shape. Ngayon yung given ni Miss is top view nasa tuktok. So ito kaya nakikita niyo diyan rectangular shape talaga siya. Yung X maliit kaysa dun sa Y para dahil yun yung rectangle. Now ang lang diyan given ay dalawang X tas isang Y. Kasi hindi yung isang naman yung intersection nila nung isang building hindi yun Y dahil iba yun. So ngayon ang tatanong kung ano yung maximum area na kayang kasi pangit naman yung magsayang ng space. So ang ni Miss, ang given, ang area daw is equal to X times Y. Tapos ngayon, yun nga, alam natin na dalawa yung X. So, 2X plus Y is equal to 800. Kasi yung given, 800 meter of fencing. Ngayon, yun, so Y. So, yung 2X, itatranspose lang natin. Kaya, Y is equal to 800 minus 2X. Kasi, ang sabi ni Miss, kailangan talaga natin, dahil nga dalawa yung unknown na variable, kailangan natin gumawa ng dalawang equation. So, ang una equation
talaga yun.
Oo, kasi transpose kasi naging negative siya yung 2x.
Oo nga.
Yan. So, ang yun nga, ang y is equal to 800 minus 2x. So, yun, nakuha na natin yung y. Sunod naman x. Ngayon, so the area A is equal to x. Tapos di ba yung y nakuha na natin, ano lang natin sa substitute. X quantity 800 minus 2x. So is equal, pag distribute natin yung x, 800x minus 2x squared. Now, to maximize the area daw, find the derivative area dA over dx is equal, kasi i-equate lagi sa 0. So, dA over dx is equal to 800. Tas, ngayon, i-derivative yan, yung 800x at yung negative 2x squared. So, yung 800, yung x, mawawala na kasi, magiging x sub 0 na yon. While yung, 2x squared, magiging 4x. Nagets naman na natin kung paano yung basic derivatives, no? Tapos is equal to 0. So, ngayon, kung iaano natin yan, yung 800, itatranspose ulit natin, magiging, yung 4x, itatranspose natin, ang mangyari dyan, 4x 4x is equal to 800. Ngayon, i-divide natin siya by 4 para cancel yung 4, kaya ang x 200. So, tatanong ni Miss kung yan na nga ba yung maximum. So, para may check, yan sa second derivative. So, yung second derivative magiging is equal to negative 4 na negative 4. Kasi negative 4 na lang kasi di ba nung nilipat natin yung yung 800, may 4x pa doon. Tama ga? Oo, yung 4x magiging negative 4 na lang. So, kaya ang negative 4x, less than siya sa 0, tas less than pa siya sa lahat ng x. Kaya masasabi natin siya yung maximum. So, the maximum area occurs when x is equal to 200 and y is equal to 400. Ngayon, kaya nakuha yung 400, yung y is equal to 400, yung x, di ba nakuha na natin 200. So, substitute natin dun sa equation na y is equal to 800 minus 2x. So, 2 times 2, 200 is equal to 400. So, 800 minus 400 is equal to 400. So, ngayon, yung area, di ba, ang area, ang equation doon, x times y. So, 200 times 8 is equal to 80,000. So, ang area natin ay 80,000 meters square. So, yun. Tuloy na yung video.
Tuloy pa ba lahat yun? Isa lang naman ata yun eh. Kaya ba? Ay, nawala. Naglag ako. Nakamute ka, Jayze.
Hintayin na lang natin. Wait lang. May another example pa yun.
Ay. Ay, hindi. Hindi ito.
Nawala si JD. May problema po ata sa internet.
Wait lang, bago mag-start, Miss, kaya hindi kami nakakapag-notepad kasi lahat kami naka-cellphone lamang.
Yun po. Pasensya na ako.
Ilan po, Miss?
Si JD nawala.
Kanina pa. Ay, hindi. Ngayon lang ata.
Hindi, nandyan yan.
Wala. For attendance.
Nawala.
Ay, nawala.
Chat mo, Hughes. Tapos,
Calling mo. Nag-scene naman. Kaso kanina pa.
may na talaga yung At siguro na.
Mahina siguro.
Play na muna natin yung ano. Tapos Yubs, chat mo na lang muna habang nag-play to.
Skip ko na to ah.
Wala atang sound. Wait lang. Hindi ko pala.
Ay, wala ba sound?
Thing. Not to
Ayan.
waste any material, not to waste any land. This is our that this is already equation number 1, and this is equation derivatives, and for all of x doing it 3D. But if you want to have this easier, you can open up the box with no top. Can you imagine it? Can you imagine a box with no top, and then you cut all the sides and open it? What would it look like? So I know you have something in mind. Just draw it out in your notebooks before I present. Because again, class, in this kind of problems, we do not give the figures. You are asked to draw the figures, create your own equations, and solve for the maximum and minimum. That is the essence of this. So we do not give the figures. We understand what the problem is, and then we, from the problem, derive everything from it. So our figure would look like this one. There would be no top, this would be open. And if you open that's how it will look like. And since this is a square base, I can say that this is x and x. All of the sides are x for this one, for the base. And then our height, this one, the height would be y, because I don't know if it's the same. It doesn't say a cube, okay? It's not doesn't say a cube box, like a cubic box. It doesn't say like that. So I need to be sure that even though it's the same, I am taking this as a different variable. Whether it's the same dimension with this, to be safe, I am making this y, okay? Because I don't know if this is a cubic box. It doesn't say in the problem. So with that, the surface area of the box is 64 centimeters squared. The area of the base of the box is x squared, of course. That is how you solve for the area of a square. And the area of each side, this one, this side, would be x multiplied by y. And how many are that? We have 4. xy, 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 and 1 x squared. Take note, this is not 2x. This is x squared. Or you can have it as x, 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 and x. You have 4 x's. So therefore, with that, I have here x squared, or 4x if that's what you want, plus 4xy. Again, this is my xy, and I have 1, 2, 3, 4. With that, I am equating it to 64 centimeters squared, and that is given in the problem. So solving for y, I have now here y equal to 64 minus x squared over 4x, or that is simply 16 over x minus x over 4. So the volume can be written as x squared y base times height. Okay, just always recall that volume is base times height. What is the base? Square, x squared. What is the height? Y. Okay, so have it as v equal to x squared y. And then substitute the value of y. Take note, class, I had 2 equations. First equation, second equation. In order for me to solve 2 unknowns, x and y, it's always the rule. It's always the rule. Now, substitute the y here, and then distribute x squared to both terms. I'll be having 16x minus x cubed over 4. Now, dv over dx is equal to 16 minus 3x squared over 4. This is after applying the derivatives. Practice your derivation now, because still, if you have the right figure, if you can draw your equations, you can derive equations, you can substitute, and so on. You're good at in your algebra. But if you are stuck with your first derivative, you cannot get the correct answer. So applying the derivative for this one, 16 multiplied by 1 minus, having the derivative of this is 3x squared over 4. It's just simply 1 over 4. You can factor out 1 over 4. Bring out, sorry, that is not factor. You can bring out 1 over 4 and take the derivative of 3 of x cubed, which is 3x squared. And then, if that is set to 0, you can solve for the value of x. We have 2, positive, negative, 8, over square root of 3, or in decimals, that would be approximately 4.62. And take note that since we are talking about dimensions, you do not consider the negative value because we don't have a negative dimension. The minimum dimension would be nothing. That is no dimension at all, 0. So the minimum dimension would be 0.00001 and so on. So note that the negative case has no practical meaning. So we use and we choose the value of 4.62 as your x. Now, is it maximum? We now apply the second derivative test to this part of our equation. Okay, so this will become 0 minus, again, bring out 4, and then apply power rule here. That would be 6x. And then you need to simplify. The answer would be negative 3x over 2. And this is negative when x is positive, so this is maximum. So the dimensions of the box are 4.62 by 4.62 and size 2.31. So therefore, if you'll be having your volume solved, that is 4.62 squared, or 4.62 times 4.62 multiplied by your y, which is, our answer is 2.31. The answer is approximately 43 or 49.3 cubic centimeter. And if you check out the material, you can always go back, and that should be equal to 64 centimeter. If you substitute this 4.62 and 2.31 in your equation here, that should give you a 64 centimeters squared. So our answer is correct. Now, maxima and minima involving trigonometric functions. Application on solving related rates and applied maxima and minima problems involving trigonometric relations and functions. A balloon rising straight up, to imagine a balloon rising straight up from the level ground, is tracked by a man with a video camera 200 meters from the point of lift off. At the moment, the video camera's angle of elevation is pi over 6. So we are talking about radians here. Your calculators must be in radians, not in degrees. So set your calculators now in radians. The angle is increasing at the rate of 0.21 radians per minute. How fast is the balloon rising at that moment? So neglect the height of the camera. So we have here the cameraman, or the man having the video camera 200 meters away from the lift off. Okay, and this is our y because we do not know the variable for this one. This is 200 meters and this is theta. Okay, now for example number 3 solution, let y be our vertical distance from the balloon to the lift off point. Okay, and we want to find dy over dt, the change of this height with respect to time. When your theta is changing 0.21 radians per second, because this is moving, of course the cameraman will be moving its camera to track the balloon. Where initially this is pi over 6. The relationship between y and theta would be, what do you think would be this? Recall your trigo functions. Theta, y, and 200 here, you can have that as your tangent. Tangent theta is TOA, that is opposite over adjacent, and you have y equal to 200 tangent theta. Differentiating y with respect to t yields to, what is the differential of tangent? Of course, you don't differentiate 200. Okay, that would be secant squared theta d theta over dt. Take note of this part. This is what I've been telling before, that take the derivative of whatever's inside of the trigo function. So this is d theta over dt because we don't know yet theta. We cannot differentiate theta as is, but we can denote it as d theta over dt. So with that, we can substitute theta as pi over 6 and d theta over dt as 0.21 radians per minute. We have our solution as 200 seconds squared pi over 6 multiplied by 0.21. And solving for dy over dt, we have 56 meters per minute. Therefore, the balloon is rising at the rate of 56 meters per minute at the moment when the angle of elevation is pi over 6. So take note, your calculators must be in radians mode. And last example, an air traffic controller is sighting a helicopter on a control station directly. The helicopter is flying 2 kilometers above the sighting instrument at the rate of 230 kilometers per hour. How fast must the sighting instrument be turning when the angle between the path of the helicopter and the line of sight is 35 degrees? So first step, you need to draw your figure. This will be our figure. Control station theta, our x, the distance, and 2 kilometers. The helicopter is flying 2 kilometers above the sighting instrument. With that, we want to find d theta over dt when your theta is 35 degrees. And we have a given dx over dt negative 230 kilometers per hour. Since x is decreasing, this distance is decreasing because it is going, or it has the direction of going to the control station. So with that, the relationship of x and theta is given by, okay, we have x, again, you can use tangent, of course, you can use tangent, x over tangent, or yeah, x equal to 2 over tangent theta, or raising the theta on the numerator, you have 2 arctan. So differentiating x and theta with respect to t, we have here the x over dt equal to negative 2 arctan of, or tangent theta raised to negative 2 secant squared theta d theta over dt, and d theta over dt is equal to negative sine squared dx over dt. Substituting all the given, we have 35 degrees for the theta and dx over dt as 230. We have now negative sine 35 degrees squared multiplied by negative 230. Our answer for d theta over dt is 75.67 degrees per hour. Therefore, the angle of the video camera is increasing at the rate of 75.67 degrees per hour. So please make sure that you're trying to use your calculators whenever we solve this kind of problems to avoid errors during your examination. You should be familiar if you're using degrees and radians. You should know when to put your parentheses. You should know where to put your squared. Okay, practice that one because that is very, very important. For your seat work number 9, you need to answer this problem together with the figure.
Yun. Also, move on na tayo sa last video. Observe. Kailangan observe. Partial derivatives. Ito yung sabi ni Miss na parang ibabonus sa atin kaya madali lang daw. Sana nga.
Good day, welcome back to Engineering Calculus 1 or Differential Calculus. For today's lesson, we will be discussing the last topic for the final period, which will be the partial derivatives. Example number 1 for partial derivative. If f of xy
Partial. Kasi yung video.
Wala ba?
Wala. Yung Facebook mo yung nasa
Alabas.
Facebook mo naka-share sa amin.
is equal to 5x cubed y.
Oo nga,
Nag-stuck
pre.
sa
Bobo. Bonak.
Ay. Nag-confess.
Minus 4x squared y plus 3.
Yan. Okay na.
Good day, welcome
Lahat
back to
na po.
Engineering Calculus 1 or Differential Calculus. For today's lesson, we will be discussing the last topic for the final period, which will be the partial derivatives. Example number 1 for partial derivative. If f of xy is equal to 5x cubed y squared minus 4x squared y plus 3x minus 2y plus 1. Find the partial derivative of f with respect to x and the partial derivative of f with respect to y. So if you'll notice, this is not simply f of x. We have here f of x and f of y, and we will be solving for the partial. Take note of this term. We are using this term for the partial derivative of the function with respect first for x, with respect to x first, and later on with respect to y. So the solution is to find the partial derivative of the function with respect to x. We regard y as constant first. So every y that we can see in this equation would be termed as constant. So how you look at 5, 4, 3, 2, and 1, we will look at our y as is like that. And differentiate f with respect to x so that we have here 15. Okay, so this is 15 because we bring down 3 here. That will be 3 times 5, 15x squared. Just copy y squared because that is constant. And x squared. Take note of that. Okay, so that will be 5. If I were you, I will be writing this down on my notebook. This will become 5y squared. Okay, that is outside the derivative sign. And then find the derivative of x cubed, which is 3x squared. So that will give you 15x squared y squared. For the second term, we bring out 4 and y, and then the derivative of x squared, which is 2x. Okay, and then 2 multiplied by 4 is 8. We have your negative, of course, and then xy. Next is 3x. The derivative of 3x is simply 3 times 1. The derivative of 2y, again, we will be looking as y as a constant. So therefore, this is constant term. This is a constant term. It's just like a number. And the derivative of constant is 0. Derivative of constant is still 0. So the answer for this one, partial derivative of f with respect to x, is 15x squared y squared minus 8xy plus 3. I hope that is clear to everyone. I hope you're also writing down while I am dictating the other solutions or the detailed solution for this one. I want you to write all the solutions in your notebook and not just listen and watch the videos. You need to do something in order for you to learn. That is the purpose for this one. Now, next, we have the partial derivative for y. Okay? This time, we will be treating all our x as constant and differentiate y as is. Okay, that is how we're going to solve it. Differentiate or regard x as constant and differentiate f with respect to y. So for the first term, listen to this one, 5x cubed. So x is a constant now, so we have that as 5x cubed. The derivative of y squared is 2y. So therefore, we have 10x cubed y. We have here 10x cubed y. Right? Next term. 4x squared multiplied by the derivative of y, which is 1. So that is simply minus 4x squared. Derivative of 3x, which is a constant, so this is 0, minus 2 multiplied by the derivative of y is simply 1, so this is minus 2, and derivative of 1 is still a constant. So the answer is 10x cubed y minus 4x squared minus 2. So this one is very easy. Just take note that if you are differentiating with respect to x, all y terms are considered as constant. And if you are differentiating with respect to y, all x terms are considered constant. Now, example number 2, we have here z equal to x cubed y squared e raised to 2x plus 3y. Find the partial derivative of z with respect to x and partial derivative of z with respect to y. So first, we write z as product of two functions. Okay, we have here the function x squared y squared multiplied by e raised to 2x plus 3y. To find the first partial derivative with respect to x, we will regard all terms aside from x as constant and differentiate z with respect to x using the product rule. With that, we get this term x cubed y squared, this one, multiplied by e 2x plus 3y multiplied by 2 plus e raised to 2x plus 3y multiplied by 3x squared y squared. And we can now simplify this. We have 2x cubed y squared e raised to 2x plus 3y. And then we have 3x squared y squared e raised to 2x plus 3y, having the simplest answer 2x plus 3x squared.
Ganito ba talaga ito nag-i-stop?
Hindi. Baka ano lang.
Nagbabuffer ata.
Wala.
Sa wifi
Galing.
ata.
Tagal magana yung loading dito. Na-stuck ko.
Ano yun?
Answer
Hindi
2x
na nag-buffer.
plus 3x squared
Hindi
Ayun,
na.
ayun.
Wala na. Ayaw na nga. Yan.
Eh di,
y
sige, diretso na
e
tayo.
raised to 2x plus 3y.
Ito patapos na
This
rin.
time we differentiate z with respect to y. We treat x as constant and use product rule again. We have x cubed y squared multiplied by e raised to 2x plus 3y times 3 plus e raised to 2x plus 3y multiplied by 2x cubed y. And then we have 3x cubed y squared e raised to 2x plus 3y. We're just combining all of this. Okay? And 2x cubed y e raised to 2x plus 3y. Solving, we have the term 3y plus 2 multiplied by x cubed y e raised to 2x plus 3y. Remember that in performing partial fractions, the operator keep in mind what independent variables go together, so he knows what variables to hold constant during a specific operation. Now, for sheet work number 10, find the first partial derivatives. So first, solve for the partial derivative with respect to x.
Yan.
So,
Doon na tayo sa PPT. Di na nakabalik si Jaydie at mahina talaga ang internet office.
ayun mga tol, explain ko na lang yung naintindihan ko kasi first, talaga hindi ko, yung mga simpleng, problem lang.
Sige bro.
Explain.
Okay lang. Okay lang.
Yan, sabi ni Miss kanina, kapag yung partial derivative, di ba? Partial derivative f with respect to x ang hahanapin. Ay, by the way pala, ito muna yung example 1 natin. So, hahanapin natin yung partial derivative f with respect to x, pati yung partial derivative f with respect to y. Then, yun, madali lang naman to. Kapag partial derivative f with respect to x, yung y yung constant. Tapos kapag yung yung y ang hahanapin, yung x naman yung constant. So, ang sagot lang dito, yun, 2x plus 0 is equals 2x. Yun yung sa partial derivative f with respect to x, tapos partial derivative f with respect to y is equals to 3y squared. Yun lang yung mga derivative nila. Tapos, second example ko, yung parang yung question ni ma'am kanina, f is x,
Palaki
y
mo nga
is equals, ay, paano?
Wait lang. Palaki mo na ni RJ.
Example pala yung mali. Solution na nailagay ko eh.
Kaya palakihan nga pa suyo, RJ.
Kita ba?
Maliit eh.
Ito na yung sagad na.
Lah,
Yung
Ni-edit
presentation mode mo.
Ay, sumobra.
Sige, ganyan na.
Ayun, ganyan.
Ayaw gumit na.
Yan. Ah,
Tama.
mano-mano na lang yung score. Yan. Okay na.
Yan. Diba, yan yung example to natin. F, ano yan? F x y is equals to 2x cubed y squared minus 4x squared. Yun lang, wag na lang natin pansinin yung y. Tapos, ang magiging sagot niyan, yung sa x, 6x squared y squared minus 8x. Tapos, so, ay 12x squared y. Kasi, sinabi nga natin kanina, constant yung x. Kaya, hindi na natin papansinin yung x dito.
Gets.
Gets nyo?
So, madali nga lang siya. Yan yung magiging parang bonus natin. Kaya, dapat intindi talaga natin. So, yun. Tapos ng,
Parang, Jayze, parang, yung kapag may kasama, yung kunwari, yung partial derivative ng x yung hahanapin, di ba constant na yung y? Pero kapag may kasama siyang variable na x, hindi na siya nagiging constant.
Basta may kasama siyang basta
Yung,
kung kuwari y, tas may included na y dun sa edi yun, hindi yun magiging constant.
Oo, parang. Kasi yun yung sagot ni ma'am sa
Pero kung siya, yung talagang
yung
siya lang.
isa lang siya. Oo.
Tsaka lang siya nagiging constant.
Oo, pre.
So, clear sa inyo lahat? Go yun.
Pag may hindi naman naiintindihan, i-chat na lang naman sa GC natin. May GC naman tayo.
Tas, sorry po talaga about kay JD. Mahina lang po talaga ang net.
Saka
Sorry
din po
din po
mismo sa notepad. Sa notepad.
Sorry din po dun sa word kanina. May nabanggit na hindi kaaya-aya.
Yan. Mag-aaral po ulit kami, miss, bagong exam. Yun lang po. Thank you.
Thank you po.
Thank you po.
Thank you, miss.